All right, so officially you're welcome to another live coding session. And in today's session, we are looking at learning Python by working on an age guessing app. Basically, with the age guessing app that we are going to be doing, we are building upon a concept that people use in mathematics to calculate your age. And it goes like this, where someone asks you to pick a number. So for instance, let's say it's sort of like a game that you are playing, and I say pick a number. Don't tell me the number that you picked. Then I say probably add 10 to it, divide by 20, multiply your answer by 2, subtract 50 from it. What did you get? And you tell me what you got, and I tell you your age based on that value that you got. Okay, so that's basically what we want to do with our Python application. A very simple application that should be able to do that. Our goal is for us to see how you approach this. Now you have an idea, as I've just shared. We know that this is something people do, but how can we program an application in Python to do same for us? Okay, and all we have at the moment is just that idea. So how do we translate our idea into code? And that's basically what we are going to be doing right now. So I hope we get the concept. Somebody to take a number. So it's basically a set of mathematical operations that are going to take place for us to, come up with the age of someone. So for instance, the first step, if you can do this in several steps depending on what you want, and there is there anyone here who is not familiar with that concept of guessing a number, as I have explained? Like they tell you take a number, this. Is there anyone who is not familiar with that concept? Like you haven't heard it before, or you haven't played that before, someone hasn't used it on you before? Anyone here like that? If no answer, then I presume everyone here has at least once in their life played that before. So basically, it is up
Oh,
to you. It is up to you to decide exactly how you want to approach it. So, for instance, let me say I tell the person to take a number. This is mathematics. So, take a number. Let's assume that that number is x. Okay, that you have taken. Then I now go ahead. You didn't tell me what your number is, so you just said x, right? Then I go ahead and I do plus 100. So everyone, let me try this. Everyone on the call, take a number. Please, you are all going to give me your numbers. I mean your answers when we are done. So please cooperate with me. Take a number and don't tell me the number, but add 100 to the number. Let's do that. Add 100 to the number. Have you done that? I hope you have. Then after you have done that, I need you to divide the answer that you got by 2. I hope you've done that. Divided the answer you got by 2. Then after you have divided the answer by 2, I need you to now multiply that answer by, to make it simple, by 10. Then go ahead and subtract 20 from it. If you need a calculator to do it, use a calculator, don't worry. So now I'm going to be taking your answers. Then for each of you, we are going to, you don't necessarily need to take your age. I mean, it's just uh okay. So yes, I asked you to take a number, so that should be a number, just a number, not necessarily your age. But later we'll look at using the age. So now let me call you one after the other. What you If you need to use a calculator, use it. Just take a number. I saw someone just joined. Please, you are all part. So take a number. Whatever your number is, the first thing I want you to do is add 100 to that number. Then after adding 100 to the number, the answer that you get, divide that answer by 2. Then after dividing by 2, the answer you get, multiply that by 10. After multiplying that by 10, the answer you get, subtract 20 from it. So if you need a calculator to do it right now and tell me. The first person, Erasmus, have you gotten your answer?
Yeah, 580.
580. Okay. Next person, Ziki. Ziki, have you gotten your answer? Hi, Ziki. Hi, Ziki.
No, I've not gotten my answer. Please, give me a few seconds.
Sure. Hurry up. You can use a calculator. So just use a calculator. Whatever number you took plus 10 divided by 2, multiply by 10, then subtract by 20. The next person, Peso, are you there?
Yeah, 500. 500.
500. Okay. Then Tony.
Hello, dog.
Hi. Good evening and welcome.
580.
580. So you and Erasmus took the same number. Interesting. Then is it money? Money master. Are you there? Money master, are you there? Adeole.
Yeah, so my result is 585.
Hey, you all decided to go through similar numbers. Okay. Monimas and Ziki, I'm waiting for you. All right, so let's see. At the end of the day, how do we know which number you took? This is like basic mathematics that we can do. Okay, so we have
Okay, I got my
x.
number now.
Okay, great. What is it?
1615.
1016. All right, great. So
615, 615,
16.
615,
Come again.
615,
615. Okay,
1615.
okay, great. All right, so let's see how we are going to figure that out. We have x plus 100 divided by 2 times 10 minus 20 is equal to, so the first person's own was 580. All right, but then it's more like this, um divided by that, multiply by this. So I can, I mean, to make it presentable in mathematical form, do it this way, right? Then this whole thing minus 20 is equal to 580. This is some of the things people see and they are scared that programming is made up of mathematics. Please, we've not started the programming. This one we are just trying. It's because the program that we want to write is kind of modeling a mathematical expression or equation. That's why we are trying to figure out how to do it, but we haven't done anything programming right now. Okay, so here we can go ahead and summarize this, and we'll get this over that, I mean times 10. Then I'll move the negative 20 to this place, so that becomes 580 plus 20. So this will give us what, 600, right? 600 x plus 100 over 2 times 10, but then I can divide through by 10 so that I get this divided by 10. I hope I'm not jumping my steps too much and you can appreciate what is happening. So now I get is equal to 60, and that means x plus 100 is equal to 60 times 2, which is 120, and my x will be equal to 120 minus 100. So Erasmus, your number was 20. Is that right?
Yes, please.
So Tony,
Right.
you also chose 20.
Yes.
Great. All right. So that's
Um,
basically how we approach it. Okay. So
Sorry,
at the end,
sir.
yeah,
Sorry.
yeah. Go ahead.
Sorry, I seems to have done a mistake.
Okay.
My answer is supposed to be 580. Five. I'm sorry. Sorry, guys.
Your don't worry. Your answer is supposed to be
525. 525.
525. All right, that's fine.
Yeah.
525. Okay, but basically that's the
Yeah,
whole
right.
process. That's the whole process. So at the end of the day, if you pay attention to it, the answer that you got from my mathematical model is basically going to be x plus 100. Let me say, so let me represent the answer you got with a y so that we get a simple equation. X plus should be very simple. Maybe I should write it down here. X plus 100 divided by 2, right? That's what I got, right? Divided by 2 times 10. Okay, so times 10 here. Then is equal to no, minus 20 is equal to y, right? Okay, so at the end of the day, y, you would know why because that's what the person is going to tell you. So our y is any of these values that you've provided, and we need to figure out what x is. So in simple mathematics term, we can say make x the subject. So we have x plus 100 over 2. Please, if you are not following the mathematics, don't worry yourself too much, okay? This is not a mathematics class. Then we'll go ahead and say x plus 100 over 2 is equal to y plus 20 divided by 10. Then we'll say x plus 100 is equal to y plus 20 divided by 10. All of this will be multiplied by 2 to get rid of this. So at the end of the day, your x will be equal to y plus 20 over 10 times 2, then all of this minus 100, and that will be x. So now, knowing this particular equation, I can take each of you your y values. So we've solved one already. Ziki said 225, so let's find Ziki's number. Y is equal to
Sorry, you've mistaken that. I said 525. So it's not okay.
525.
You can continue. Yeah.
Okay, sorry about that. 525. 525. Oh, okay. So sure. Y is equal to 525. That means x is equal to 525 plus 20 over 10. This multiplied by 2 or minus 100. So 525 20 will be 545. Then divided by 10 will be 5.4.5 times 2 minus 100. What is
Okay.
54.5 times 2? What should that be?
That's
55 would have been 110, right?
109.
109.
109.
Okay. 109 minus. So
Minus
this is 109 minus 100, and that is 9. So Ziki, your number that you chose was 9. Is that
That's correct.
great? So at the end of the day, we should be able to get everyone's number. And this thing is not constant, like 100, 2, 10, 20 is not constant. You decide exactly how you want your calculation to go, what you want the person to remember, or I mean do, but you keep track of it, and you make sure you get your mathematical expression right. Okay, so if I'm going to put this into code, what I'm going to do is kind of come up with an equation like this. Okay, I'm going to come up with an equation like this, and I'll now program my code such that the number that you give me, my code should add 20 to it and divide the outcome by 10, multiply that outcome by 2, and subtract 100 from it, and that should be x. So this time round, you tell the person, all right, I know your age. Okay, So instead of saying take a number, you say I know your age. And if you think I'm joking, now let's do this. Let me prove that I know your age. Add the number 100. So let me just start another one. Say add 100 to your age, then whatever you get, divide that by 2. Okay, then after you are done, multiply that by 10, and whatever you get, subtract 20 from it. So this time around, I didn't say take a number, I said your age. So the person knows their whoever we are talking to knows his or her age, and they are going to use their age to do it. And at the end of the day, all of this is equal to a value, which is y. So we have to just make x the subject in this equation, and that will help us get our y and our x value. And simply x over, I think it's the same thing that I just did, right? Plus 20 divided by 10, x will be equal to y plus 20 over 10 times 2, then minus 100. I think it's the same thing I did. Oh yeah, so my brain couldn't change the values. Anyway, so just by doing this, I said you should take your age. So at the end of the day, I'm able to calculate and get your age. Do we all get it? Is there anyone who is confused about the mathematics behind it, so that when we start the programming behind it, you don't get confused? Are you okay with the mathematics aspect? Is everyone okay with the mathematics aspect?
Yeah, we're
Yeah,
good.
I'm okay with
I'm
it.
good. I'm
Hmm.
okay with it.
Great. So now we are going to look at how to implement something like this in code. And I've said that these values that we are currently using, you can change them. You can use any sort of values, provided you tell the person that these are the values I want you to use. Okay, add this, divide that, multiply. We can do it as many times as possible. All we need is for you to tell us your answer at the end of, have a mathematical expression that gives us your answer. Then from that we can deduce the value that you chose, in this case your age. Okay, so Adeole, are you ready?
Yes, boss.
Yeah, so let's see how we are going to implement this in code. I believe that there are several ways that we can approach it, but at the end of the day, what we are going to do is we are going to display a set of information to someone. So for instance, the title of our program, or yeah, our application, this is an age guessing, maybe a game, or I mean however we call it, an age guessing app. And it starts off by greeting the person and say, hey, I know your age, can I guess it? Then if he says yes, I should guess it, I say okay. So let's say add 100 to your age. What is the output? Don't tell me, keep it in your mind. Add this to it, divide that, like any set of values that we choose to use. Then eventually we now tell the person to enter the outcome of the calculations they've done. Then after we have received that value, we'll go ahead and do our calculation and say, okay, you are this age years old. I hope that's fine. So let's see how we're going to implement it on code. Now I'm handing over to you, Adeole.
Okay. So if we take this way, usually you want to have an algorithm. So the steps in your process before you code. Okay? Mujib, why are you? Somebody else is
Hi, Mujib.
typing.
Please stop typing. Let him work on it. As and
Okay,
when
okay,
we need,
okay.
yeah, as and when we need you to type, he will instruct you to do that.
So usually when I'm trying to code or solve a problem, I like to do my whiteboarding or like quasi whiteboarding inside text editor. And I like to use the Python doc strings. Right? So the idea is to get X value in Y value. Right? So we have a value, say just like pseudocode. So just use English no code. You can say say program to calculate a value x, right? A value x, right? From a value y.
So
Say
for just for those who are new to programming, this is not the actual programming that he's doing. Okay, he's just writing like the steps that he wants. So we call it a comment. I mean, he explained it, but just for emphasis sake, we call it a comment, and it doesn't necessarily play a role in running the program, but then it gives you, the programmer or anyone who is going to be taking a look at your program, an idea of what your program is about. And anytime you return back to it, you know exactly why you wrote the code that you wrote. So that's what he's doing right now. All right, so just go ahead.
okay. So I assume that you're already giving the user the explanation of how to get their y value. Tell them to choose a number and do the math. So it's not the part of this comments block.
Okay.
So you're just walking back from the y value, right? So we assume that user is going to pass there are different ways to pass a value into a program, but we assume they're going to prompt them and using the Python input, right? So you say you take the y value using the inputs function. Right? Then you now go back to the steps from the math model that it was talking about. You want to calculate the x value from the y by reversing the mathematics. So he came up in the end, he had an equation, right? So that we want to write that equation here exactly. So Doc, can you read that equation to me? The last equation you had.
Okay, let me quickly go there. I'm coming. So at the end of the day, it's going to be y plus 20 divided by 10, all multiplied by 2. This is our mathematics. Then there should be a simpler way to, a way to simplify this equation, right? This could be simplified further. So that should be y, or we could
Yeah,
we
just
could
want
even do this divided by that 5. So y plus 20 over 5 minus 100, right? And
minus 100.
that's the same as y over 5 plus 20 divided by 5 is 4.
That's
4 minus 100. Y over 5. Hey, I hope I'm not making a mistake. Y over 5 minus 96. Would that work? So let's see with the first answer that was given was 580. So let's try 580. 580
So in
580
this case,
divided by 5.
wait,
So
is this equation correct? Let me something.
that's what I want to confirm. Well, let's
So you want
wait.
to say 5
80 divided by 5. That is 116. 116
okay, yeah, that's putting the
minus
value.
96. Right?
Yeah, that's 20.
That's 20. And that's what we got
Yes.
initially. Or
Yeah, yes, that was
yeah,
initially.
yeah, so
So
it works. So let's use the
let's
summary.
try for an odd
Okay, we
right?
try with another one. We use 525 here. So for 525, yeah, so what we are doing right now, even when you are programming, you are supposed to be doing that. We call it testing. Okay, so for those of you who are new, that's very important. Even though we've gotten a formula, we've calculated one and it has worked for us, but we are not sure if all cases will pass. So we have to try different cases to make sure that it's able to correctly pass for every case that we use. So at the moment we want to use the 525 over 5 minus 96, and that gives us 525 divided by 5 is 105,
What's 105?
minus 96 is 9, and his answer was 9. So I want to believe that it's working. So yeah, so at the end of the day, Adele, we are using is equal to y divided by 5, then 96.
So y divided by 5 minus 96.
Yeah.
So this is our final. Okay. So okay, since this is the comments, yeah. So this is basically what we want to do. We're okay to take. Is everybody okay with this as a comment for getting the x from the y value?
Anyone who has a
Is there
concern with that? I think we can proceed.
so because we're using Python, I just want to say y is equal to inputs.
Okay.
And you enter a prompt. I don't know, but let's say enter a number. Right?
So your y would be like the final value they get, right?
Yeah, the final value you get. So I'm saying, like, I assume that there's a part of the program that generates the prompt for them, right?
Okay. Okay. Sure.
After that, after all that has happened, I'll get to the
So
point where they have to
so
enter.
let's update the prompt to something like enter your is it your final answer or something? Yeah.
Is this okay? Enter a final
Yeah.
answer. And we want to bring this line from our back.
So let me just say something just for the new people, at least they get something here. All right, so those who are new to programming, what happens is that when you are working with programming, at least there are two main things that you look to be doing. One, to be able to display something to the screen for your end user to see something. Then two, to be able to take input from them, like whatever they type on their keyboard, you should be able to take the input. And every programming language has a way of approaching these ones with regards to displaying information to the screen and with regards to taking input from the user. So in Python, we call this a function. The input that you are seeing there is a function, and it's whenever you use it, it allows you to take a value from the user. Whatever the person is going to type on their keyboard, you are going to capture that and store it. So here what he is doing is that whatever this user is going to type, he's going to store it in y. So it's like if the user typed 5, then you say y is equal to 5. So anywhere you use y, it's equal to 5. Okay, but the good thing about this input is that it allows you to also display information to the user before they type something. So here we are going to display enter your final answer to the person, and the person will now enter. So if it was Erasmus, Erasmus will now enter his 585 as his final answer. Then once he has, I mean, you the programmer, you have gotten the value that the user typed, you are then going to use that value to do your calculation, which you've already estimated that this should be the way to get the value. So he's going to go ahead and get that x. Yeah, I don't really, you can.
Okay, so just one additional thing here. So the nature of the input function in Python is that you always return the string.
Exactly.
So, and because what you do, you have to do some work on this. So you have to wrap, you have to cast, it's called casting, as changing data from one type to another in a program. So you usually just use the ints, right? So you wrap this around this, right? Yeah. Okay. So if person enters 585, if it's entered as a string, that's just a sequence of characters, not a number. But this way, you are promoting that input to y as the number, right? As an integer. That's the whole number, that's fractions. So you can see the explanation says int x, integer. So it converts a number or string to an integer or return 0 if the arguments are passed. So this will help you change whatever you're getting from the user, which is a string, to a number, right? So since you now have y as a number here, if you want, you can print it, right? Just to check that you got it right. And that's how I usually do that step by step in my program, so that you know when you have bugs, right? So, but you now have your y now, you can then proceed to do this in code, right? So if you want, you can just say, just this will work, right? And just say x is equal to y, right? Minus x6. Right? So you say, should this work? You say, okay, let's try it. X, right? So if everything works well, your program will output to the screen, or I guess to the screen, the X value, which is the user's guess, the number that they chose but did not tell you, right? So this is the simplest form of this program. It's just 3 lines. This is not part of the program, right? So this is something else, right? And this is actually not part of the program either. So it's just 3 lines in Python. If you want, you can even make it 2 lines, but it won't be clear, right? So this is the simplest form of this program. Obviously, there are things that will make this program get a bug, or there are edge cases that you have to test for. But in the simplest form, if the user always passes a valid number that is not too big, there's a range, right? This will work, right? So we can test this now by plugging some of the values that we have, some of our y values as y, right? And see if it works, right? So should we try that?
Yeah, sure.
Okay. So isn't it once that use
You can
replace?
the shell here to run it.
But it still saves automatically, right?
Yeah, it does.
Yeah. Do I have to do ch mode?
No, so you'd have to run it with Python 3.
Yeah, no, that's saying. So Python 3, and our shell is called main.py, I think.
Are you typing? I can't see it.
Yes. So enter your file. Can you see my screen now? I've run the script, right?
No, I can't see. Interesting.
Anybody see?
They are seeing my screen alone, so if I can't see it means they can also see.
Type the shell,
Oh,
and I can see the prompts on my screen.
but can you share your screen? If you can share your screen, let's display that instead. Unfortunately, that wouldn't also show in the recording. That's interesting. But why?
But you can't. What are you seeing on your screen?
The shell, you're running it with the shell, right? Because the
Yes.
shell here is empty. Does it mean
Interesting.
each of us has our own shell, I guess?
Those might have our own shell. So let me share my screen. So can you see it now?
Let me see your screen. Where is it? Okay, this is your screen. Okay, so we can see your screen right now. Unfortunately, it wouldn't appear in the recording, but anyway, I hope everyone can see. If you've not seen it, look for
Yeah,
you can see it, right?
yeah, I can see it.
Okay, good.
Yeah.
Good. All right.
We have a list of our Y values, right? So I think the first one was, what was the first one again? The Y value, first Y value.
I think it was 585, I guess.
If we enter 585 into our program,
580. 580.
I say, I say 20. This was my number. As I tell you, it turns 21, which was the number I chose, right?
Okay.
So one thing I notice is that anytime you do a division in Python, like we did on line 5, it returns the fruits, right? So if you want, you can then cast this to an integer again, right? But this is the answer is 21, right? So depending on what you want to look, right, you can then cast this to an integer if you want from a float. A float is a decimal number, like in math. So if we do this again, right, and we enter 5 as the Y value, it returns 20, right? So if you want, you can then add the print statements. You can say the number you choose was let's use let's say you want to use fast string, right?
I don't know. Have you tried using the F string on ALS tags before?
Yes, of course.
Does
Sometimes
it
they
work?
actually specify. Yeah, sometimes if you actually specify they have to use it.
No, like
Or
when
recently,
the ones they don't specify.
yeah, sometimes it doesn't work. I noticed that
Uh-huh.
in
Because I've also been I like
I
using
think
the F string, but then every time I use it, unless when they have specifically said you should use it, it doesn't work.
so. I don't know what the problem is. Sometimes it
No,
works,
I
sometimes it doesn't.
guess I guess the checker probably may be running a version of
So,
Python that
yeah,
doesn't like was
F
prior
strings
to
were
the F
introduced
string.
in 3.6, I think. So maybe there's an older
Exactly.
version. Right?
Exactly. That's
So
what
if
I
I
thought
run
as
this
well.
now,
Okay.
and right, somebody's answer was 525, I believe.
Yeah, 525.
I type in 525, right? You see, the answer you chose was 9, right? If I want, I can change this to just 9, no 9.0, right? By saying, yeah, I want to say, I want to wrap this in an int score, right? Say int, right? Right? So if I run this again, why is it not? Okay, yeah. It's not letting me recall my last command. Python 3 main dot. If I provide 5 to 5, say the number you chose was 9. So this is how to make your value from a float to an integer. Initially it was 9.0, but now it's 9. So you see that we added a string to make the outputs like more, how do I say, just makes the output better. Right? Instead of just returning the number as we initially did, right? Now we're returning a statement that said the number you chose was, and I presented that number back. Okay. There are little tricks like this that you pick up when you're programming, like to make your program more interactive. For example, you could have used on line 8, you could have used the input function without providing a prompt. It doesn't really make sense, but you could have done it. And the same way, you could have returned the number here without adding any prompts. Like a calculator. If you enter any 10 plus 17, it just returns the number to you, right? But this one, see, because there's now text that you can read before you get your number. So, but in the simplest form of this program, this is what you have, right?
Yeah.
So it's like fairly, like, we said yesterday, for those of you that were on the talk, programming is just, this is something that anybody can do. Anybody that can code can do this if they get this. A problem that they don't understand, if they get a step by step, which is what this is, right? Or a pseudocode, they can code this part. As long as they understand the syntax of the language. And that's why you often see problems that they are language agnostic. They'll tell you, solve this problem in any language that you like. So it's up to you, whatever language you feel confident in or you feel is the best fit for this problem, right? You then implement your solution in that problem. But this is what is important. So because we had this already, I didn't have to start figuring out this math myself. I already had this process. I knew what I was going to do. I knew how to do it. I could write this easily. So this is the actual problem solving. This is meditation. Sometimes you run into problems here, right? But this is where you run into majority of the problems when you're solving many problems as a programmer, right? So this is you can make this. You can train this program to do many things. And if you want imperative code, that's line by line. You can break this program out to about, I don't know, from 3 lines to about 10 lines. That the flow will be easier to follow, right? You could do the math on like 3 steps instead of just one single expression that is condensed here on line 9. You make it like 3 or 4 lines. So you can see the flow, how you went from 525 or 580 or 585 to this number. You can see how the math works. And these are magic values now, right?
Mm-hmm.
When whoever posed the riddle to you or the question to you, there were no 5 in his question, or it didn't tell you to do it with 5 or 96. So you can't tell how these numbers came to be. But if you use the original values that you were given to modify your X value, you can walk back and you can see the process better, right? So that's another way to write code. But in the end, this works. You get your X value from your Y value. But for readability, and especially as a learner, you usually want to see the steps, right? So you could write this code in 5 or 6 different ways for different reasons, right? But this is the simplest version of the program.
Great. So the other thing I want us to do, since we called it a age guesser, I want us to update this, let's say, to your age, just so it suits the purpose. So your age is right. Sorry, is this, or instead of your age is maybe you are this years old, or your age is that. That works. Then I also want us to, just so it doesn't look magical as it is looking right now, let's bring in the prompts that all the user, like exactly what the application is about and the steps that they were supposed to take, where they were supposed to do some additions and all those steps. Let's bring
The
them.
original prompt that we shared on the call before we started, right? You say, are you typing or should I type?
I'm coming. Let me just, oh, I wish I typed this thing out. Okay, let me type it out here quickly. So it's basically x plus 100, whatever you get, divided by 2, multiply by 10, then subtract 20. So we are going to run this step by step for them. I'm just trying to, oh, you've closed yours. You could have still maintained it anyway.
Okay, I thought you were going to actually code it as well.
No. I mean, I'm just bringing it so that you know the steps. That's all. So the first step was the person should take the number or their age. Like you tell them, hey, I know your age. So do you mind if I guess your age? Okay, add 100 to your age. Then what you get, divide that value by 2. Then the output, multiply it by 10. Then subtract 20 from it. And we will now proceed and tell the person your age is this. So yeah, however you want to approach it.
Usually for stuff like this, in our case, it's a computer program, so you want to present this information to the user. What I'll just use is just prints the whole prompt, right? As multi-line prompt.
Okay.
I could just say as in this example, you can say this is a program that guesses your age. Right? I'm going to say so you say add 100 to your age, right? Right? And you say divide sum, or divide this sum, right, by 2. Right? And you say multiply this number by 10. And you say subtract 20 from this number. Right? And then we just ask them to input enter your final answer into the program. Right? So if I was to do this now, why is it not giving me my history? Let's say Python 3 main.py now. See, it gives you this prompt now. So this is a program that guesses your age. Say add 100 to your age, you do the math in your head. Say divide this sum by 2, you do the math the calculator. Or let's say multiply this number by 10, subtract 20 from this number, and enter your final answer. And you enter your final answer. In our last example, it was 525. Right? And the program says your age is
Great. I like the simple approach that you have used regards to using the multi-line. In fact, this is it's actually not something I've ever done before. I almost always end up writing multiple print statements. Yeah.
usually I use French strings to the backslash, now add a new line. Right?
You know, when you started, I was going to ask, don't we need to add new lines in there? Because I'm not used to it. Anyway, so those of you who may see this to be strange, like when you are writing, these are like uh programming language specific things which we call the syntax, how you write particular things in a programming language. But then whatever you are trying to achieve, there is a concept behind it. So what you should do your best to understand is the concept. As for the syntax on about how to do it in a given programming language, so now we are using Python to do this. You could equally write the same program in C. You could write it in JavaScript, any language that you could write it, and the
I even write
concepts
it,
are the same. Come again, I didn't hear that.
I even write it in Bash.
Exactly, yes. So at the end of the day, the concept is the same behind all of them. What differs is how we approach it in the specific programming language, which is the syntax of the language. So, for instance, here he has used this print statement to print out all of this, but then you realize that they are all on different lines. Hey, sorry, I mean, I'm sure you people are not seeing when I'm in here. Okay, you see that, but then let me highlight my screen right now, at least just for the explanation purposes. Okay, so you can see that all these lines were printed out, even though they are printed out on separate lines or individual lines. He actually wrote them in just one single print statement, which is this one. Okay, and that is the approach that you take when you are working in Python. It may not necessarily apply to other languages, but at the end of the day, you know that whatever language you are using to do this, first of all, you need to display something to your screen. And most programming languages end up using print. Some will use echo, and yes, in JavaScript you use console.log and all the others, printf and things. Yes, so whatever it is, at the end of the day, you should just know the fact that if I want to display something on the screen, this is how I approach it. Okay, I don't really another thing, another way that I would like right now I'm thinking of is to use like input to guide the person. What I mean by that is, okay, now I know your age. I want to guess your age, but I want you to add 100 to your age and let me know when you are done. Okay, so that the person doesn't get confused. Like I want to guide them through. Okay, are you done?
Okay, you want to do
Add,
it step by step.
exactly. So add 100 to your age, and if it says like they are done with that, okay, now add divide what you got by 2. Now go ahead and multiply what you got. So at each point, I want them to show something that they have done it. Okay, so I don't
Okay.
know if we
So
want to take inputs
how
of
we
0
go
and 1.
about that? Do you want to take inputs in like in a let me just
So that's what
so
I'm also thinking, that maybe we should be taking input of
more right?
what
So you
yeah,
could say, for example, say this is a program that guesses your age, right?
yeah.
So you could say add 100 to your age, and you could ask for inputs. The classic cases, yes or no, right?
Mm-hmm.
Or Y or N. So that's what it is, right? So say add 100 to your age, and you could say enter Y when you've done the math, right?
Exactly.
And the person enter. That's one way to
Exactly.
go about it. We try that.
Yeah. Yeah, let's try that. So relax, don't delete this one. I prefer we
Yeah,
create a new file so that let me create a file and call this is guess.py. Okay, then copy the content from here. Okay, so now let's work from the hguesser.py. I hope you can find it at your end.
yeah, I can see it in the yeah.
All right, so let's work with that.
So in this case, you want to add uh, inputs, and for the shift that's we'll be adding a well, okay, what do you want to do? How do you want to implement exactly? So you check a conditional if the you can use you print it line by line. Say this is a program that guesses your age, right?
Mm-hmm.
Um let's say let's just close this. This is a program that guesses your age, and you can ask or let's just use the same principle. Say do you want to check it out? Say and by 4 years and for no, right? So we could then do an input. Actually, this will probably be in the inputs, right? So you want to say answer is equal to so this case say enter Y for yes and for no. So this is the classic. This is what you actually see in most terminal-based interactives. You ask
Yeah.
you to enter Y for yes. Then you want to add the if answer yeah, the easiest way is just say if answer okay, let me just create see the problem is it's supposed to be a basic one, but usually what I like to do is to create a list. Right?
Mm.
So you say positive is equal to create a list, right? You can say y, right? Y. Yes.
That's Interesting.
Say negative is equal to n.
I'm happy that we are getting a list in here, at least so that it also introduces the concept of list to people who don't know.
Right? So they say you can make any program idiot proof, but God will make better idiots. So you've asked your why for yes or n for no. The most obvious case for creating a robust program is that they may enter lowercase y or lowercase n, right? Which is very easy.
Yeah.
Have your caps lock on, you mistakenly hold shifts, that happens, or
Yeah.
you can't find your caps lock or something, right? That happens. But also people want to type yes. But they've seen the yes, they want to type yes, and you also want to handle the same case. Maybe don't use title case, capital Y, the rest of the word, the lowercase or all caps. So this is right a more robust way to handle that. Then you can then say if answer in positive, right? Do something, right? And in this case, what we want to do is print this statement. Right? In this case, it would be I want to add the new print statements. Right? And in this case, we want to add rate your age. Why is it not selecting text? Right? So you say answer, I don't write your age. And if you want, you can then add another prompt where you're taking I don't write your age, right? So add another prompt. Depending on what you want, you also want to do if the person says no, right? And if answer is negative, or just say help, right? That's what you need here. You don't need to explain what the else is. If the answer is not in that positive string, you could then print something like, okay, actually, too bad. Goodbye. Okay. So this person, the person has entered a positive number. Your program continues to run after this block, right? And you now want to say, you want to give next prompts. You could say, or say, do you have that number, right? At the answer is equal to input. Right? You could then give another, say, let's say, I don't know, have you done the math? Right? Say answer is equal to inputs. Say, do you have the number? If you have some yet, right? So again, you bring your the same line of if answer in positive, right? Yeah, that's every time I'm just checking, right? Or if you say instead of a yes or no, right? You assume that anybody that is answering this first part intends to continue all the way. You could then say yeah, there's an answer here. You say just ask again. Say if answer in positive, right? You then print the next prompt, right? You can say something like in this case, let's say let's promote this to our response. Let's say print divide this sum by 2. Right? So then you could then go again and say the same, just again you could repeat this block of this line of code. eventually you get to a point where you'll be written a block of code. Oftentimes you want to spin that off into a function, but for now, let's keep this simple, right? Okay. Do you have this is nice sum, right? Okay. Do you have the what's the
Quotient.
so,
Is it quotient?
yeah, sure. That was it. Yeah. So let's keep it simple, right? Yeah. So yeah, so you come straight to here, like say,
Oh, but at the end of the
if
day, I think you can even use output or like outcome, something like that, to make it simple.
yeah, so I
For
was
somebody who doesn't
like,
even know what the quotient is.
you doesn't know what quotient is. You don't want to provide any. You don't want to be the person providing the bugs to your user. Your users already. Yeah. So then you want to check again if this answer is positive, right? Say if answer is positive, right? You want to print this next line. So you want the person to do this, right? So obviously, as writing this program, because we are doing this on the fly, you get some bugs, right? What did the person type, right? You're not handling. You're asking if the program just talks, right? So you say multiply this quotient. Let's say quotient. Multiply this quotient by 10. And then you ask, do you have the answer yet? Do you have the, let's say it's our product, right? Do you have the product yet? And then you check again if you have the answer, right? The if answer in positive, right? Then print, promote this, your response, you say print, then give you a string. And you then have your final answer, but the rest of your program is still the same, right? So, does this make sense? You're trying to make your program more interactive, obviously, and everything you add to your program is a potential breakpoint, and then introduce bugs into your program. But for a program this simple, I don't think we missed any obvious thing, but we'll find out when we run it, right? So, let me try to run this. Why is it printing everything at once? Oh, I'm running main.py. Sorry, no, this is the old program. I was waiting there. Python 3.
Age guesser.
Yeah, so this is a program that guesses your age. Do you want to check it out? And I say, why? Right? Okay, add 100 to your age. Okay. Okay, do you have that sum yet? Right? You see, this is the first bug, right? And I'm not telling them to enter Y for years. That should be a part
So
of it.
the person can just hit enter.
The person can just mistakenly now enter the math answer that they have, the answer to these
Oh,
products.
okay.
Yeah.
But even
So for
on my
example,
end
now,
that I'm
if I add,
testing,
yeah,
I just hit enter without typing anything.
exactly. So that's it. You just keep going because enter, right? So you see, it just keeps doing, but it gives you an error at the end. So that is the problem with making your program interactive. You have to now handle exceptions and stuff like this, right? So invalid literal for int with base 10 because your empty string is a valid input for the input function. When you want to promote it to an integer, you come into a problem, right? So yeah, so let's play this and let's start again, right? So am I interested? I think so. Right? So let's go run to the program first, giving it like the right output that we expect, where we now fix the flow. So do you have this sum yet? Okay, I had a number. Yes, I have the number. Divide this sum by 2. Okay. Okay. So it takes a little while longer to do division than addition. Like, okay, I have the number then. I press yes. Why? See, multiply this quotient by 10. I mean, maybe I don't know what quotient means, and I have to look it up on my phone real quick. Okay. It just means the product of multiplication. I do okay. Yes, I have this spread there. This time I type yes. They subtract 20 from this product. And the entire final answer. Okay. My final answer is 585. Here is 21. So in the best case scenario, the user's inputs are within your what you expect, right?
Yeah.
And this works. Unfortunately, it really goes like this. And so if I enter no here or n, right? It says too bad, goodbye. You see, it still goes to do you have the sum yet?
Yeah.
Right? So it continues going. So I'm not ending my program or anything. It just keeps going. So do you have the sum yet? And I say no. It goes to do you have the quotient yet? And I say this time I'm shouting like all caps. I say no. Do you have the product yet? I say, and it keeps going. What is your final answer? And I say 0. He said your age is my 36. Right? So this is how you can break a program that was working initially. You're trying to make it interactive, but you now have to undo different cases. Right? So how will we fix our code to reflect this? Right? We say this is the first part we are asking for inputs. Right? So the user is asking, okay, this is the program that tests your age. Do you want to check it out? And you ask for input from the user. But yes, if answer is positive, add 0 to else print too bad goodbye and do what? At this point, the rest of the program should not run anymore. Because the person has said they don't have credit in your program. So your rest of the program should not run. So how do we achieve that? Right? You want to add something in this else block that will stop the rest of your code from running. Right? How do you do that? And no ideas. Can you guys hear me?
Yes, yes, we can hear you. So, hi, those in the audience, is asked a question. How do you think we can approach that?
If the person says no, they are private or they don't want anybody to guess their age for whatever reason, and they print no, the rest of this program should not run or anything in this list. And the program has printed goodbye, but it's still working. That's not good. So what should we add here to prevent the rest of this? Any
No,
ideas?
Noah has an idea on that. So, from my end, I think we'd have to import the model sys. Then
Okay, exit the program, right?
come again. I didn't.
So you can exit the program.
Yeah, we can exit the program exactly.
That's I think that's the best way to go about it. Right? So you can import right? You hear me?
Yeah, we can hear you.
Yeah. I think putting a module too advanced for this audience. Or what do you think?
I mean, you can still go ahead and do it.
Okay.
At least you were once in a live stream and you saw somebody do that. So when you get there, you know, oh, this is why the person did this.
Okay, so let me say imports. So if person says choose um before you even doing this, you can just print all exit, right? Exits. I think it's your exits, right? And so the program should not. Let's start to see if we are correct, right? Because it might be wrong. You want to
I'm guessing that the exit may have to come after the print statement.
right? So, you want to check it out? And I want to say, okay,
Yeah, so
see, it doesn't just print, so you want to bring it.
exactly. But that exit card, shouldn't it be able to take a like an input, the string in there? I don't
Yeah,
know.
yeah,
I'm
yeah.
thinking.
Yeah, that's exactly how Python works, right? Yeah. So if we try
So
this now,
great.
that say too bad, goodbye. You see, we are instead of asking them ones that they've told you that they're not interested in, just use um method. Right? But let's say interested and they say yes. Then goes on to add 100 to your age. And it says, do you have this sum yet? You can change, yeah, well, this is a good, you can change this. But if you hit enter, right, it goes on to the next, yeah, so you get there. So you can change from, so this is actually part of, if you're interested in game design, uh, prompt side, an integral part of game design. It's ready for text-based games, right? So you want to make your, have to write to take efforts. Whatever things. Sometimes you'll be using numbers, sometimes you'll be using it's like simple like words, right? So yeah. Yeah. So in this case, mm, that's that the person wants the game. We add 100 to your age. So in that's what I was talking about. Because the way this prompt is written with the colon at the end, the person might think you wanted to enter some, right?
Yeah, the value they got or something.
Enters value now. I say, for example, I had 30 in my mind, and if you add 100 to your age, and I say, do you have the sum yet? I say 130. He says, do you have the quotient yet? Right? And I say, no. Say, do you have the product yet? And I say, no. Because I this question, right? Because my condition is only going to print this next prompt if
Yeah.
your answer is yes, no, if is why, yes, 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 or yes, right? The other thing you print is like is a no that is not in this thing. It doesn't print. This is problem with conditionals. It's only going to print this block of code if the answer to this is yes. So if the answer is getting is not in this list, it's not going to print this part. So because I'm not doing anything, these cases, one answer I say 130, right? And he said my age is minus 70. So I don't know how that's possible, but that's what Dr. Obet my age is. So we face one problem with our reporting the exits module or function from the system module. So how do we handle this, right? So this is the more robust your program is your work, your sweat that makes it robust, right? A simple program works because it's simple. If you want to make it more interactive, you want to add features to it, it's your work. You add coding more things into it, and you also have to handle stuff like this, right? There are bugs or whatever you could make, I just call them, right? So how do we handle this now? In this case, do we return our prompts? I say, if you ask, for example, say, hit enter when you have the sum. That's another way to draw about it, right? And in this case, you take away this line of code, right? And then this will run, right? You say, hit enter. Now, you have the code running. Like, you are letting them generate the prompt when they've done the math themselves, right? So should we try that?
Yep.
Should we try my network?
Yeah, your line is shaky a bit, right? You know.
No, I'm saying should we change our prompts,
Our prompt.
right?
Okay, I'm coming.
It says, should we change our prompts? Hello.
Yeah, I didn't really
Saying
get like.
should we change our prompts? Like we say, hit enter when you have the sum, or something like that.
Yeah, we can we can work with that.
That's some like change
Yeah.
this to yeah. So okay,
Which one is return? Is there a key called return?
yeah. So if you use a Mac, the enter key is label return on Macs.
In I didn't know.
So you want to click with this, right? And then you want to print this, right? So you change that part. Right? Let's run it. Okay, this is the program that you're doing it. I say hit enter return when you have this done. So I've done the math and I hit enter now. Now says divide this sum by 12. Right? So let's now change the next thing from if to the same thing, hit enter. It is
Yeah.
this one is quotient, right? Print. Right? So run this, we print this now and run. Oh, I haven't closed. Yeah. So yes, I'm interested to add 100 to your age. They hit enter when you enter the sum. I've done that. They divide this sum. That they hit enter. Okay. Multiply 10. So it's the same thing. If I change this to the same thing, okay, product, this is product. So I delete this. If I run, sorry, our, so yes, I am interested. That's nothing. You have a typo like this now.
Mm-hmm.
It's a big, yeah, but I don't think we can talk about that. So yes. So add on the page. Let me take that. Okay, yes. I have this one. No, divide this one by 2. We hit enter. Okay? So it takes me a while, but I have it done. Please multiply this question by 10. Hit enter return when you have the products. So my final answer, as always, is 585. The age is
Great.
21.
Great.
Okay? So this, let's say there are bugs. Right? So if you're running the program, and somebody says, yes, they're interested, and then if for some reason they type something else, like it doesn't make your program, like just messes it up. Right? You can't hold down a bug. Right? So right? No, no, no. It's kind of more robust. You can't break it by entering no. Maybe the only way you can break your program if they're bad at math. Maybe after my calculation, I get 105 or 102. You see, your age is 75. I guess the only bad math that can only break this flow of this program at this point, besides the typo at this point.
Okay.
Yeah.
So in the case of let's say catching the bad maths there, I think we can use a conditional to check if the answer they gave us is zero or less, like less than one.
No,
Then say
it's not that's what they give us, it's our X, right? It's not
yeah,
we are
yeah,
doing it.
yeah. I mean after we do our calculation, when we get the value for x, if x value is anything zero or less, a negative number, then we know that they probably didn't give us
If
the.
X is less than
So let's use less than or equal to, because if it is equal to
Y,
zero, who is
then
zero is good.
kind of nowadays they are very precocious, so they fit on the code. They don't doubt it. Say that we say print print, say that can be correct.
So probably what we can also do is put this conditional check and the printing in a loop where we expect them to enter the right answer. So for as long as they've not entered the right answer, we keep sending them back to the prompt where they are supposed to enter their final answer.
Oh, okay. You want to pick uh, this.
But then you for now let's go ahead and make sure it's working. If it is working
Yeah.
the way we want it to work, then we looking at the loop part.
Okay. Let's say yes, and I come. That can be correct.
Mm.
So this works. But if we run it again, that uh, that that do this. Mathematical in this case is now 585, right? So this it works up to this point.
Okay. So let's try the loop.
Okay. So you want to say um, okay, to do we have a value for y or x?
Okay. So
So if we play with x, we could say while uh, x is less
okay,
than or equal
yeah,
to 0.
yeah, that works.
Then instead of doing this
Yeah.
can be correct,
Mm,
you could then do
the prompt.
entire final answer again.
Yeah,
Yeah.
yeah.
We
So you tell them that can be correct. So you first of all print that can be correct. Then you now go ahead and tell them to enter it again. Then now let's make it enter the correct final answer.
say since the prompt is going to be there for them, and I say do the math again
Mm.
and enter your okay.
Yeah, that's
So let's use doctrine. Does this work for inputs? Let's try.
that's interesting. I didn't even think about it.
Let's try this one. Let's say my final answer is now. I think it was 1 and 2, right?
Yeah.
Says correct. Do the math again and enter. So it works for
Mm,
inputs, right?
yeah. Like
Take away.
it's bringing in the space that you added.
Yeah. No, I invented, Pycode style and Pepe, right? So
Okay.
it's
Yeah.
that. Do the math again, enter a final answer. So let me edit this. Okay? So it's here. There's no pet 8 holding me here. So let me live my best life. Let me say 5. Yeah. Why is that?
Hey.
It's not in it. Why is this? What do we
No,
miss?
no, we are using the okay, but now x. Oh, we haven't calculated x again. So x is still
Yeah,
x.
yeah, hold on. So
So
this
after
is
a while,
the
we are
simple.
supposed to calculate x again.
Yeah, so print
That's inside the while loop.
just say you can't. Okay, let's try this.
No, the line for calculating the x value.
X, yeah, yeah, it should be up above it. Bring that in as well. So,
Great, this should work.
so let's try this again now. So my final answer is okay. I have to close this and run it again.
But it's still going to. We have to run a conditional in there.
You said while x is equal to 0, so
Mm-hmm.
I'm assigning x to break out. Well, let's see if it works.
It will print your age is x before it breaks out of like it runs the loop again.
Okay,
Unless you bring a break statement after that. like using a
Well,
conditional to check. Yeah, so this works. What you have right now works because you have taken it out. Yeah.
I mean, cancel this, and create, and everything. So let's see. Yes, this, and that my answer is 1 and 2. So that can be correct. Do the math again. Okay. From here, don't my age, blah, blah, blah. Okay, this time I have 585. Your age is
Great.
21.
Great. Great. That's excellent. All right. We've we've done how many? Close to 2 hours. So let's take questions from the audience, and I'll try and also I'm coming. Let me get back. I'll try and summarize some of the concepts that we've learned, because as I keep saying, the concept is what is important. Okay, what is important is the concept. Great. Let me share my. So anyone here with a question? At the end of the day, we've seen him use these concepts. I hope you can see my screen now. I'm about to write something.
Let me stop sharing.
Guys, are you there? And can you see my screen? Okay. So some of the concepts that we have used this evening and how we use them. Well, we initially talked about accepting user inputs and also displaying an output to user. Accepting user inputs. Hey, sorry about that. So in Python, we use the input function. We've also looked at displaying output to the user, displaying outputs to user, and we use the print function in Python. All right. Then what came in, I think what came in that I was happy about is the fact that we used lists. So list was used as a collection for options that were provided. So at the end of the day, he anticipated that even though he's asking the user to enter Y for yes and N for no, the user may end up entering, you see here he has capital Y. Some people may end up entering the small letter y. Others may go ahead and type yes, and there may be variant forms of the yes as they type. So he's considering all of them. For that matter, he has collected all those as options in a list. Okay, so a list in Python we call it a list, but then in other programming languages, such a collection may be given a different name, like an array. So if you are working in C, you'll be talking about arrays. JavaScript, you'll be talking about arrays. But essentially, we're just looking at a collection of data put together as such, and we can access each of them when we want. So that's how he brought in the concept of list. Then after the concept of list, he introduced what we call conditionals. So he used the if condition, conditionals. He used the if condition to check if what the user, we've asked the user to type an answer, but we want to be sure or want to be certain that what they typed is in any of these or that. So it's a condition. If the answer, here we are accepting the inputs into a variable called answer. For those who are new to programming, you'd also have the concept of variables that is used to store the data. So whatever the user enters, we are storing it in a variable called answer. Then this particular variable, we come here and check if whatever is in this variable, which is the container, this answer, whatever the person typed, is it present in this list? Remember, positive is representing this list. So if any of the things here is what the person typed, then we go ahead and say print this, add 100 to your age. Else, if they type anything outside this, then we went on to print too bad, then we exited the program. So another concept was introduced for the exit, and that was working with models or packages. Okay, so there are some functionalities that are external to the program that you are writing, and as and when you need to use them, then you call for them. So here we're looking for a way to exit our program when the person choose not to continue, and the one way that we know of is to use a model called sys. And in Python, actually, the sys model is like it gives us access to your system itself. Okay, so when we anytime we import the sys model or we use the sys model, there are several functions in the sys model that helps us reach, kind of like we are trying to get access to your computer and do things inside our Python program. So that's the sys model that we work with. And here, what we are able to achieve with the exit function from the or exit method from the sys model was for us to be able to close our application if the person decides not to continue. So that was a concept that we dealt with. The rest is still taking input, displaying. Then eventually we looked at loops. I think we've covered quite a lot. Please give me a few seconds. Let me open my door for my brother. Come. Yeah, hello. I hope you can hear me. Sorry for that. So we eventually ended up using loops, but in our case, we use the while loop. So there are different types of loops, and depending on the programming language that you are looking at, we can have different ones. We can have the for loop, we can have for each loop. They are not present in every programming language. I mean, like the concept of loop is present in every programming language, but the the specific type. So each programming language has the type that is available. You can have the do while loop. I've even seen until. Is it do or until something in some programming languages? So the concept of loop is just, hey, keep doing something until a particular condition is met or otherwise. Okay, so that's basically it. If I say keep joining our live sessions until we are not holding live sessions, it means anytime we are doing a live session, I want you to join, like something like that. And if we are not holding, obviously you are not joining. Or like these are practical things that we do all the time. So in our case here, we were asking the user to enter their final answer that they were getting, and we went on to check whatever answer that you give me, if it's truly correct, I don't expect your age to be less than 0. And I also, yeah, like 0 or less. Your age can be 0 or less. So for as long as the value you provided is not ending up giving me 0, then I'll go no. So here we said for as long as it is 0 or less, we are going to prompt you. Okay, that means that when we get here and we check and x is greater than 0, all of these things will be skipped because we didn't meet the condition here. The condition is for us to check if x is less than or equal to 0. Then we go ahead and do all of this. But then as soon as we get here and we realize that x is greater than 0, we are going to loop. Then we come to this line to print something. if x is less than or equal to 0, we'll come in here and say print that can't be correct. Then give them another input, ask them for another input, then do your calculation again, get your new x value. Then we check back again. If x is still less than 0, tell them that can be incorrect. They should keep doing it. So eventually we get x that is greater than 0, and we get out of this loop and come to print the age for the person. So I like the way this whole thing has gone. The interesting part
Yeah.
is that before we started, we had no idea how we're going to implement it. So at the end of the day, we just had a mathematical model for guessing someone's age. We try to explain how it works, and even though I mean, the calculation that we did here, the values could be changed. So now I want to challenge you: go use your own set of values, tell the user to pick a number, add 10 to it, maybe multiply the outcome by 50, subtract 2 from it, and divide everything by 32. It is totally up to you. Like, at the end of the day, the mathematical model that you are going to use, or the algebraic expression or equation that you are going to use, is totally up to you. And once you have reached how you want to approach it, then you can proceed to go and do the coding. And interestingly enough, we've been able to incorporate very important concepts in the program. So try them on your own. Try learning, especially these ones: the list, the conditions, and the loops, because those are very, very important working with them. I said in other programming languages, lists are called arrays. Any questions? If you have any questions, especially the newcomers, this is time to start asking questions, so that at the end of the day, when you start learning it, it becomes easier for you because you saw something like that somewhere. Any questions?
Okay. Sorry, I have a question.
All right, sure.
Can you hear me?
Yeah, we can hear you.
Okay. For the district,
Now
can
it's
you
breaking, so I'm struggling to hear.
Lánàá òun máa mú nọ́mbà wá.
Oh, hello, Kel. Is it Kel or Kel?
uh yes, totally yeah, yeah, yeah.
Okay.
Okay. You said can you go back to the um,
The code.
yes.
Okay.
Okay, you see what I'm talking about for six input. What I want to ask is why do you have to put was if you put the exit command when the
Why
run
why do we have to? I didn't get. Why do we have to?
what? Yeah, go back. You have to go back and write that before we add before you have to write the exit there. Did you
Hmm.
get my question?
No, I don't really. Can you hear him?
I can barely hear him, but he's asking us. I think he's asking why we had to do that. Like we had to use the exits. I mean, on line 20, 21. Sorry, is that right? Is that what you're
Oh,
asking?
this one.
That's why we have to write that before we put the command exit.
Okay, you know what? You can type. There's a chat channel. You can
Yeah,
type.
Okay.
try using the chat. We can hardly hear. So use the chat. Oh, someone was complaining they couldn't speak. I muted them.
Was like 2 hours ago.
When he joined, I think. Oh, okay. Like there was noise coming from his end, so I muted him. All right. As we are waiting for Kel to type his message, any other person with a concern? Hi, Barokin. How are you doing? Yeah. How are you doing? Great. I think it's high time I connect my GitHub repo to Replit so that I'll be pushing them to GitHub
Good,
too.
okay.
But you know, Replit, they have also made this into like I think it's a version control system. Like they have something like that.
Yeah, I saw that the screen is under tools. Go to tools, you see it.
Okay.
Yeah, so you see they have Git integration, right? So
Yeah.
and the foundation for most version control systems. So GitHub just works on top of Git.
Yeah.
So same does, so you can then manage your repos or push to replace from your
Mm.
Git timeline or your desktop, whatever,
I,
your
I
GUI.
li- I I really like what they are doing. Uh, Recently
They have
I saw a demo somewhere where you know this AI upsurge that is going on. I saw a demo
yeah, so they
somewhere
have like,
about Replay where you use voice command to tell it to write something for you, and it does the writing of the code for you. I don't know if
interesting.
maybe I don't know if it's in bit, but one of the guys I follow on Twitter shared that video. Oh, so his question is why did we have to come here to put when we needed it down when we needed
Okay.
the exit down here? Why did we have to put it up?
Uh, there's a
Hello,
part
can you hear me?
Yeah, we
yeah,
can
we can
hear
hear
you.
you.
Okay, sorry, my imagination. Um, do you think quite
Yeah, we've gotten a question from the chat now. So Adeoli, you want to take that?
When you want to use something in most programming languages, a variable, a function, an object, whatever, you usually want to introduce it to your program earlier. That's the idea of declaration, hoisting, definition, right? So in the Python convention is that you add your imports at the beginning of your program, right? So if this was a proper program, we'll delete lines 2 to 8. These are just like comments to help you understand the logic of your program. So this program actually starts from this line 10. So that's just a convention. You want to add your import statements at the beginning of your program, right? That's why you do it. If you want, you can import inside your program, right? There's actually nothing stopping you for your own programs to do it. Obviously, you can't do this for ALX, but for your own personal use, you can do this, right? If you're bringing this import statement into, for example, inside your else statement, right? Say on line 21, or even line 20, and you need to add it, add this here. I don't see any reason why it shouldn't work, right? The best one, I haven't tried it because I was taught to use imports in a particular way, but it should work, right?
Oh
But the
yeah.
convention for good programming, right? And the Python idea is that you read your code more times than you run it, right? So for you to be able to read your code at a glance, right? This is the convention. You import all your imports for your program, and you add 2 blank lines after them. So you have a clear visual block that okay, this is all the modules and packages and objects and functions I'm importing into this program, right? And then you have is kind of extra, but another way to prevent imported code from running is something like if name is equal to main, right? So that's different. Like, but the point is, you import all your code at the beginning of the program. You add a check to prevent imported code from executing, and then you write the program. It is just convention. That-
Yeah. So as you have heard, it's a convention that we follow. It doesn't mean if you do it otherwise it wouldn't work, but then that is more almost every time when you open a script like a Python script, as you mentioned, this is just comments and it's not part of the code. It's just information to you, the developer, or whichever other developer that is going to see your code. So essentially this is like the starting point of your program where you are importing some things, and in a bigger project you end up importing a lot of models. Okay, not just one model. Depending on what you are doing, you may end up importing a lot of models, so you want to always have them in that specific location so that anytime you want to confirm that a model was imported, probably you're having a problem, you want to confirm that it was rightly imported or not, you just know exactly where to look them up. Okay, so basically that's why we prefer to have it up there. And there are times too that it becomes essential. I mean, you may start getting into some errors because you call this maybe here because there was a print statement here. Let's say if we decided to import this here, we could have imported it here before using the exit. Okay, but then since we imported it under this else statement, it means we can't come to use that exit function anywhere else in the program except within this block of code. So once you are being introduced to programming, you would appreciate what a block is, but then all we are saying is anything under this X statement is a given block. When we get out of it, everything here doesn't apply again. So now we can use this sys model that we imported or the exit from the sys model anywhere in our program again. But then you may want to use it multiple times. This means that if I want to use the exit here, I have to come and copy this whole thing that do another import. Okay. And the moment you begin to appreciate what import is, you realize that this file, the sys that you are importing, is more like another Python script that someone has written, and you are going to copy and come and dump in your program. So if you are importing the same model multiple times, what it means is that you are copying the same code and dumping the content of your code in your own program multiple times. So at the end of the day, you are just wasting space and you are slowing down your program. So the best is to ensure that you import the thing right. Oh, okay. You import the thing right at the top. So I'm only importing once, and because I imported it at the top, this is now available to every code that I write in this, and I don't need to import it again. So that's the
Okay.
main
Yeah.
reason why we do that.
Thank you, sir.
You're welcome. All right. Any final questions before we bring the session to an end? I like
Okay,
how
let me
our
just add
program.
the
Sure, sure.
same principle applies in C as well, right?
Yeah.
In any programming language, when you are bringing external code into your program, it's convention. There are reasons, right? But the convention is at the top of C. You have it, right? The STDIO, the STD, right? So same convention that because you're bringing code that you then not to use, but you then be using, right?
Yep. Oh, okay. So I've enjoyed the time here today, and I hope you also did. Once we made the code open to everyone, try your hands on it. So we have two versions. We started with this version and we ended up with this version. And even with this, there were iterations along the line. And that is the part that I always want you all to see, that you don't start out writing perfect code or the code that corrects everything, like everything is on point. You have to think through it. Sometimes we could have thought through exactly how we want to approach it even before we start. That is possible. But then sometimes you just don't even know what you are about to do. So what you do is you break it down, take the smallest bit. So you see how I actually approached it. He started off by writing the part where we are just checking the final answer that the person is doing, and we are doing the calculation to get the age, and we are printing it out to them. That was like the basic functionality that we need for our program to work. So we start with that. Then now we start adding the superfluous stuff that we believe will make our program more user friendly. Okay. So at the end of the day, there were times that you saw he and myself doing like contributions on that. And that's what I always encourage. Like, hey, in this your role as a software engineer, you should be able to communicate what you think, your thoughts, should you should be able to communicate with your colleagues, get feedback, and refine anything that you are refining. So yeah, I like the experience we had today, and hopefully in subsequent sessions too we'll have similar experience. And I don't want it to be Adeole the next time, nor myself. We want you all to get involved. So next week, one of you should also try volunteering to write the code. Even if you are new to this whole thing, hey, write the code. The more you write, the easier it is even for you to understand. So even if I don't know how to write, I don't know the syntax of a language, I can still go ahead. Okay, you guys are here to guide me, right? So how do I do this? Then they tell you, oh, okay, then you do. It is. I think that it will be one of the fastest way to learn anything at all. So hopefully next week we'll come up with another project idea, then do it. Uh, I think a lot of people complain about not having project ideas to practice. And I feel that working with projects like this is like one of the best ways to learn. So one of the things I'm thinking about is having a collection of these projects that we are going to be working on, simple projects like that we are going to be working on, and maybe documenting it in a form of like assignments or something. So we'll have maybe on a website, you go there if you want to learn Python, like the way here we've used this concept. So we have a project, you come and you get the uh let's say a tax, which is like a project. So in this project you are asked to build an age guessing game. Okay, and make sure to incorporate the following concepts. Then at the end of the day, you submit your solution for review by others. I'm thinking about something like that, but then we would soon. It's still in the thought process anyway. Let me not jump the gun right now. I'll figure out how we'll do it. But for now, we are going to be working on similar projects, giving you the exposure. Then the nice thing too is that when you implement this in one programming language, the moment you want to learn another programming language, just try implementing the similar thing in the other programming language, and it will be easier for you to transport your knowledge from one programming language to the other, especially because you understand the concepts beneath it. So, more importantly, even though we've been able to build an age guessing app, what is important is that you understand the following concepts and how they were used in the particular app that we just built. All right, so thank you all so much. Or if there is a final question, on my count to 5. If there are no questions, then we bring the session to an end. Uh, 1, 2, 3, 4, 5. Sorry, AY. Today you came when we were closing. You're welcome anyway. So at
Grace.
at the end of the day, thank you so much for your time, and I do relate to a special thanks to you for availing yourself to help us do this work, and to everyone else. I mean, the weekend hasn't ended yet, so the goals that you set for yourself for the weekend, make sure you continue with it, and hopefully next week, Friday, right? Friday we'll meet for our tech parties talk. Then on Saturday we'll have another live coding session. So I hope to see you there.